presentation on projector technology, basically the theory of how they work and everything. Not so much on the maintenance and stuff like that because we went over that with Neil already. So there are 3 different main types of projectors: the CRT, cathode ray tube, LCD, liquid crystal display, and DLP, digital light processing. The CRT was not really used on UWL. I don't think it is at all as far as I'm aware. But some of the pros is that it has a long service life. It has a superior black level, which is basically just the blacks are actually black. On some LCDs and stuff, the blacks will be more of a gray color and they won't be completely black. And it's got a fast response time with no motion blur. But the cons are they're really big and heavy. They take a really long time to set up and adjust, and they're not very energy efficient. Plus, they're prone to burn-in, which I'm sure you're all aware of. If you leave a TV on or something, you'll get that image burned into the screen, and it'll just kind of stay there. And they work by having basically 3 separate CRTs, each with their own lens. There's the red one, the green one, and the blue one, and then they all focus in on the same spot on the screen to give you the overall image. Then LCD one, this is what we do use on EWL. They're relatively slim and light, they're very easy to move, and they're pretty portable. And they're very bright, and they all have at least high definition resolution. They don't suffer from burn-in, but they do have dead pixels occasionally. And like I said before, the black levels on LCDs aren't quite as good. And the lamps are pretty costly, and they must be replaced pretty often. And they work by splitting a light source into red, green, and blue. And then each color passes through an LCD, and a current is sent through the LCD screen, causing the liquid crystal inside to align in such a way that it'll bend and it'll adjust the amount of light that's allowed through each pixel, so you can customize the color in each pixel spot. And then they combine all 3 of the lights together to form one as it passes through the lens. And then this is a little diagram. I don't know if you can see the mouse, but it splits the light into those, and then they pass through the LCDs and recombine, and then out to the lens.
Well, I think that it is worth to look at this closer, so everyone will really look and saturate your mind with that picture, okay? This is very important. I want you to look at this very deeply, and I might ask you how many mirrors we need in LCD projectors or something else. So I really want you to.
Okay. Then the DLP. I don't think this is used on campus right now, but it might be used in the future more often. And like the LCD, it's very bright, has high definition resolution, and it has the best contrast and absolute black levels. So that's an up from the LCDs. It doesn't suffer from the burn-in, and the image quality will not fade with time. Dead pixels are very rare. They do have a rainbow effect, which is basically if you have an object moving across the screen in a very dark background, some people will notice like a blue or a green or a red trail following it. And that's something to do with the way that they work. I'll get into that more often later. And like LCDs, the lamps are pretty costly and have to be replaced pretty often. So this is how they work. The light passes through a spinning wheel, then it gets focused on a DMD, a digital micromirror device, and the DMD contains a ton of microscopic mirrors. Each one corresponds to 1 or more pixels. The number of mirrors corresponds to the resolution, and these mirrors can be repositioned rapidly to reflect light through the lens or to a heat sink. And here's a little diagram. And the way I understand it, which causes the rainbow effect thing, is it kind of does the red, and then the green, and then the blue separately. It just does it really fast. So we see it as one image. But what's actually happening is it's displaying the red, then it's displaying the green, then it's displaying the blue. So some people will notice that we'll kind of see the separation, while other people, they'll never notice it. It's just the way some people's eyes are, I guess.
Yeah, I also want you to look at this.
Then for lenses, there are a few different types of lenses. Right now they're in range from like how close the screen is to the projector to how far away. The short fixed lens is the shortest distance, and then the super long throw lens is if the projector is really far away. And each of these has a different lens throw ratio, and that's represented by the distance from the projector lens to the screen over the screen width. So if the throw ratio is a 2 to 1 and the projector is 14 feet away, then the display width will be 7 feet long. So the larger the ratio is, the more tightly focused the display will be. So the super long throw lens has a larger throw ratio than the short fixed lens or the standard lens. These are the projectors that we have on campus. The G5650, which is in Centennial classrooms, and 8000s, then the ones in the normal classrooms, and all the other buildings is the 5200 for the Epsons. We still do have a few Proximas around campus, but we're slowly getting rid of those. For troubleshooting, one of the things that might happen is it won't turn on and off with the control panel, which happens a lot in Centennial. And basically what we do there is we just turn the system off and turn it back on, or we unplug the projector and plug it back in, and usually that fixes it. Another problem would be that it has no image or a dim image. So you just make sure the projector and the input source are both on. The bulb might be burnt out or worn out, so you might have to replace the bulb or clean the lens. And if the image is the wrong size or getting cut off on the edge, then you'd have to change the resolution, either on the scaler or the projector itself, or possibly both. And these are different light codes. This is for the Epsons. If the lamp light is flashing orange, it means to replace the lamp. If it's flashing red, it's already burnt out or it's overheating, so probably needs to be replaced. For the temperature light, if it's flashing green, the air filter is clogged and you need to clean the filter. Flashing orange, it's overheating and might shut down. And if it's solid red, it already overheated and it shut down to prevent damage. So that's something we should keep an eye on. And if it's flashing red, there's a fan or temperature sensor problem. Then the power light, solid orange, is it's on standby or off. flashing orange, it's cooling down, and you won't be able to turn it back on until it's cooled down and it goes to a solid orange light. If it's solid green, it's on. If it's flashing green, it's warming up and turning on. And if it's red, there's a problem, and there's probably some other kind of code with the lights, and you have to go into the manual and see exactly what the code is. And Proximas, if it's blinking, the lamp light is blinking red, the lamp is dead, and we need to replace it. If the temperature light is solid red, it's overheating. And then if the lamp light turns red and you replace the lamp, the projector still won't turn on. So what you'd have to do is shut it down completely and then turn it on while holding the up and down button simultaneously, and that will reset the lamp light, and then it'll allow it to turn on. I think it resets the lamp hours as well. I'm not entirely sure about that. The main things that we do for maintenance is clean the filter, replace the lamps, and then make sure you reset the lamp hours and the filter hours if they have filter hours. I don't think the Epsons do. That's it. So any questions?